Hello and welcome back to Calculus 1, Exam 1 Review. So, exam is next class, which is next week, and we have chapters 1 and 2. Why is it red? Chapters 1 and 2. Click. Look at that. The power of it. So, chapters 1 and 2, 10 problems. And, yes. So, 10 problems. You are already familiar with your 7 quizzes which are going, and they will conclude on Monday, which is the day of your test. Make sure you solve all those quizzes in a timely manner. And the exam is going to be clocked at hour 20, hour 25, okay? So, hour 20 is the official time for the class. And then we can go maybe 5 minutes through the break. After that, I will lecture probably 3 and 3-4 to catch up. I was planning on doing 3-3 tonight, but then you started working on your lab, talking about cars and vacations, so yeah. All right.
I thought you said 120, and then I processed.
120 hours? I can come up with the exam for 120 hours. It's just, the problem is the no bathroom. So, 120 hours of no bathroom is.
I processed 120 minutes. Is what actually.
120 minutes is 2 hours. So you can do that.
Well, that's why I was confused.
So bring your bladders, please. Don't leave that stuff at home. So we have chapters 1 and 2, 10 problems, hour and 20 minutes, and the regular test-taking skills. You read the entire exam first, solve stuff that it's extremely easy for you. Remember that we are all born different, so what's easy for some of you would be harder for others, and vice versa. So jump around and solve everything that it's quick for you and easy for you. The goal is to have the half of the exam done in the first 20 minutes. And then you can enjoy the rest of the exam at the slow pace, right? Don't get stuck on a problem number 1 for 35 minutes, because that's how you fail. So jump around, do whatever you can. I did tell you that the definition of a function will be on it, because that's the most important concept that we need to survive Calc 1. Most of your exam is from chapter 2, and we're going to have some chapter 1. So, chapter 1, definition of the function. We have graphing. We have function composition. We have inverse function. So this is your chapter 1, and I would say 3 to 4 problems, no more. Most likely 3. Well, actually, like 3 problems plus the definition of a function. So there you go. Definition of a function is only 4 points, so, or 0. No partial credit on that one. And then we move into chapter 2. We have 2.2, limits by chart and graph. 2.3, limits by plugin and algebra. 2.4 infinite limits plus vertical asymptote. 2.5 limits at infinity plus horizontal asymptote plus end behavior. 2.6 continuity, which breaks into continuity at a point. Global continuity, and then we have continuity theorems, and finally we have piecewise continuity at the end. 2.7 definition of the limit plus 2 pictures with explanations. So that's the entire exam, chapters 1, chapter 2, 10 problems. So you have the limits, infinite limits, and limits at infinity. They are connected to asymptotes. You know that's extremely important. These asymptotes are not going away for the entire course, including your future calculus courses and differential equations. So this is the overview, and you hopefully remember that in 2.2 you learned the 2 methods that work all the time. Graph method: if you have a graph, you can read the limit off of the graph because the limit is just a y value. But then that might not be precise if the graph is crooked, sloppy. What if you don't know how to graph? Let's say you never learned in your pre-Calculus1 how to graph those 10 or 12 basic functions. Then in that case you can't use the graph to come up with the limit. Chart is something that works 100% of the time on 100% of the problems. However, it's annoying to calculate those values, and if you are not sure, it's easy to make the mistake when you have problems that oscillate. So chart is, charts sometimes need to be supplemented with a graph. In most cases, chart is going to just grind through the problem like nothing. But if you have these very quick oscillations and you are not picking values that are far apart enough, you might get wrong answers, and obviously that's a problem. So charts and graphs are good, but they are not perfect. 2.3, I said limits by plug-in. So your first way to calculate limits should be to plug in the value that you have, and that will only hold if you get an actual number, like 7 or 1/3. If you have 0 over 0, you have 0 in denominator or the infinity or something, plug-in method doesn't work. And generally we use algebra, and algebra breaks down, as if you go back to our section in your notes, algebra is broken down into these few concepts, and that is you factor, or you rationalize, or you perform some algebraic witchcraft to convert your problem so that you can cancel and then plug in. Infinite limits and vertical asymptote. We said that even if the either left or right limit needs to have answer to be infinity, and you have a vertical asymptote, the problem might say prove that function so-and-so has the asymptote at, and I give it to you. So it's not, you can't just state, oh, asymptote is at 3. Well, I gave you that. Your job is to prove it, which means just run the limit. You just compute the limit as x goes to 3, let's say, and if you get a finite number, it's an open circle. If you get one of the infinities, it's a vertical asymptote. Limits at infinity, that would be the horizontal asymptotes and end behavior. So this is where the x goes to infinity or x goes to negative infinity. Generally, we like to look at the graph for these ones. So, basic graphing is necessary. And then we have the end behavior with those 4, right? The chart that had the 4 going up and going down, 2 going up, 2 going down. That is a mathematical way to describe the end behavior of the function. Moving on to continuity, you have to memorize those 3 rules, obviously, for continuity at the point. Then you have to memorize those 2 theorems. One is the list of all functions that are globally continuous on their domain. And the second one is that the combination of continuous functions and composition of continuous functions are all continuous, so that you can deal with a more complex problem in the limit. And finally, piecewise continuous. I already seen this problem. Someone brought it up at one point, and that is that the statement would say, oh, maybe I picked that for the quiz. I'm losing my mind. Just have 6 classes. I have no clue anymore. I give it. Piecewise continuity is you have the function that is discontinuous, like 1 over x, but that function will have continuous pieces. So what are the pieces that are continuous? So for 1 over x, you would say negative infinity to 0, union 0 to positive infinity, meaning it's continuous on each one of those intervals, and it's discontinuous at the 0 because that's where it's interrupted with the vertical asymptote. Finally, 2.7. The definition is given to you, notes are uploaded, and then you have those 2 pictures with the 2 paragraphs explaining what those pictures are. Remember, no problems from 2.7. That's reserved for honors section. If you're interested, stop by my office. We'll work it out inside. And that's it. The question is, since we only have 2 minutes left and then another 55 after that. So if you have, if you have any questions, I can answer. Any problems? I need a problem. Yes.
Can we go over x minus 1, x minus 3 over x plus 3, and then find the limit of that as x approaches negative 3?
That's not on the lab, right?
That's on the quiz.
Today's quiz?
Yeah, but I mean that changes. Something changes. I just wanted to know, like, if we had a problem like this, do we have to graph that ourselves?
What does it say? Limit?
Limit as x approaches negative 3
of
function x minus 1, and then x minus 3. Well, actually, the numerator is x minus 1 times x minus 3, and then the denominator is x plus 3.
Like this?
Yes, sir.
Yeah, there we go. It's ugly, but it worked. I have to move it, it triggers me. Alright, so there we go. So yeah, you're doomed. You have to graph. And these types of graphs we will cover in chapter 4, section 4.4, I think. So this would be deemed as too complicated without aid of technology, because you didn't learn technique for this. So something like this is not likely to be, not going to be there, because you can't graph. You can graph it. Come up with a X and Y chart with 20 values from -10 to +10, right? And then compute their Y values, and then you graph that. So yes, you can graph this using middle school method, but it's going to take a long time for you to compute 20 points. You can't just go from -2 to +2, because you see that the function gets interesting at -3. So your good old algebra chart from -2 to +2 to compute and show something is not going to work, right? You might want to compute from -5 to 1 or 2. That would capture -3 asymptote, but again, best bet is to go from -10 to +10, compute those, and that's just a lot of annoying picky work for you to graph a function. So yeah, we would have to have something. Now, this is okay to be on a lab, obviously, and your homework, because you have access to calculator and other graphing utilities to deal with this. Now, you will be expected to do a graph of this by hand on the exam 3, because chapter 4 is teaching you the methods to graph this by hand. No limit, right? Just a function. So yeah. Any other questions, concerns, problems for me to solve? Yeah.
If the limit is infinity, then does that mean the limit does not exist?
We say yes, but we say it's infinity. Existence of a limit means it's a finite number. But if the limit is equal to infinity, you still put infinity as the answer. You don't write the NE.
Okay.
So the answer to this question is yes, but still write the infinity there. Yes.
So on the test, for the notation for if the limit does not exist, we can just put DNE. Well,
yes,
obviously
DNE.
limit equals, okay.
No, you would not say limit equals. You have to put a function in there. Okay,
Yeah, limit.
that's a very good thing. Yes. So you know, but let me just go on the broad. Please, here is another thing that triggers my allergies. So I'm going to fix this problem, and I'm going to say x plus 1 divided by x minus 2. So now this becomes a simple limit to solve, which you can solve just by plugging the value in, because the denominator is no longer 0, and you have -2 over -5, which is 2/5. Now, what you see here is the 100% correct notation. If you box this at the end, that's even better, and that's the end of the story. Now, there are certain demons that go around which possess students to, after you solve the problem correctly and display the problem correctly, do this. Limit equals 2/5. Oh. No. You have to have a function. You have to say where the limit is going to. So if you are going to do this, you're either using the full notation. If you put this down, I have to take a point off for notation. And I do right. Every time you see like this, you immediately know you triggered me. All right? So the correct notation is to use the limit in every step until you are ready. So let's say you have limit x minus 4 over x squared minus 16 as x goes to -4. Let's say this is the problem that you have. To solve this limit, you know you have to factor. You have to copy the limit with x goes to -4 because you are not using that now. That's an operator. You have to copy that. And then you have x minus 4 x minus 4, x plus 4. These cancel. And now you have to solve limit x goes to negative 4, 1 over x plus 4. Note that I wrote the limit with the stuff underneath all in every single step because, again, I am not using it yet. Now I am realizing, oh, this is the one of those that I have to solve with the graph, because if I plug in this in here, it is going to give me 1 over 0, so plug-in method doesn't work. And there is nothing else I can do here in terms of factoring and rationalizing and all of that kind of stuff. So now we know that we are supposed to graph the 1 over x, 4 units left. Very good. So you will draw a graph. You will leave. You will put the vertical asymptote at negative 4 because everything goes left, and then you will just put your 1 over x, regular 1 over x, in there. So it's very simple to graph these basic graphs, which are shifted left, right, up, down, and so on. And now you see that the left limit goes to negative infinity, right limit goes to positive infinity, so the limit does not exist, and the x equals negative 4 is vertical asymptote because, I mean, you see it on a picture, but we also see that the left limit goes to negative infinity, which is sufficient for us to claim that at negative 4 we have a vertical asymptote, because one of the one-sided limits worked out to be infinity. So make sure that your notation is correct, and you don't have any of those situations when you just say, oh, limit is 3, and you go. Right. You are allowed to do this. That's 100%. Limit is 3. Because you spell out proper English sentence, or you can use mathematical sentence of whatever the value is, right? So you can use English sentence, or you can use mathematical sentence. This is nothing. Yeah, it's absolutely nothing. This doesn't belong anywhere, so no. I also told you that VA equals 3 is no. Ha equals negative 7, no. Right? None of that stuff. That is not proper mathematical notation, and you should not use it. Otherwise, Gandalf. No one saw the movies, like that's ancient, right? Okay, good. Any other questions, concerns, problems? Yeah?
I just wanted to confirm there's not going to be a problem on the test that has to do with the epsilon delta.
Calculation-wise, no.
But the pictures? But you need the pictures?
Yes. So when you go to 2.7, update that. This is it. The red statement. Here's the first picture with the explanation. Here's the second picture with the explanation, and the lecture is over. I'm actually going to erase all of this stuff because it has nothing to do with anything.
So if we copy that exactly as it is.
That's exactly what you're supposed to do.
Okay. And the picture is in the book as well?
Yes. They have the same better graphics. They have better resolution in the book. Anything else? I have 1 minute left. and then another 45 after that. It works best on the test. 3 minutes left, and then another 50 after that. He wakes everyone up. If you were at that point, if you were snoozing just a little bit, like 3 minutes left. Oh, and the 50, that's 53. See, it prompts you to do math. 3 plus 50, 53 kind of warms you up, and then you just kick in, right? Do another limit. After that. Yes. Yeah.
And there's like a fraction like really complicated. Because like I can do the simple ones, but complicated ones.
Get the problem.
Oh.
Yeah. This is where you give the problems, I provide the answers. The next class I give the problems, you provide the answers. Swap.
Okay, I have
All right, let's see what you have.
it's a fraction. So the numerator is 3x squared plus 2x plus 1. And then the denominator is x minus 1.
And then what's the limit going to?
2.
Limit is going to 2. All right. So the question is on limits, and we actually got lucky with this question because the plug-in method works. When you plug in 2 in a denominator, you get 2 minus 1, which is 1, so it's not 0. So this problem, we can quickly plug in 2. That will be 12 plus 4 plus 1 divided by 1, which is 17.
So we do want it to didn't work out, like if it was as x plus 1.
So can we do the same question if it approaches 1? Let's see. That only depends if I can factor and cancel. If I change this, that's why you need to find a problem that...
Factorable.
Is it?
No, that's not.
It's not. Yeah, because it's 3...
What do I mean?
3x plus 1 times x plus 1 I have to have, and no. We can't use this problem. We have to use something else. No. It's a graded material.
I have a question.
All right. Did you find it?
Yeah, I found
Good.
I found that.
What do you have? Limit x goes to...
To 5.
Okay.
And then it's a big parentheses, 1 over x squared minus 4x minus 5, and then it's minus 1 over 6, and then parentheses 2 minus, or x minus 5.
Like this?
Yeah.
Woohoo! Nice. Yes, so we are going to factor here and see what we get. So what do we have? X goes to 5. 1 over. We have x... x plus 1. Yes, very good. X plus 1, x minus 5. And the second parenthesis is second term is 1 over 6 x minus 5. So to find the common denominator, I would have to multiply by 6 over here and by x plus 1 over here. So let's see if this works out. Limit x goes to 5. We have 6 minus x minus 1. Nice! 6x plus 1 is minus 5. Now it's limit. X goes to 5. And you have, on top, you have 5 minus x. Yeah, we're going to factor out the negative. X plus 1, x minus 5. So now, if you remember the formula from algebra, if you have a minus b, you can factor out the minus, and then you get to swap, and it becomes b minus a. So I am going to factor. Note that I'm writing this limit 5,000 times because I'm not getting to it yet. So negative x minus 5, and then 6x plus 1, x minus 5. These cancel. And I have finally limit negative 1 over 6x plus 1. And now I can plug in 5. So it's going to be negative 1 over 36, because now we can plug in. So we use the algebra to add these, well, subtract these fractions. And luckily this worked out. Minus sign is too low. There we go. So 6 minus 1 is 5. So we get 5 minus x. And we have x minus 5. So we have to use the formula here to factor out negative and swap the order. So x minus 5 and x minus 5 cancel, which kills x minus 5 in the denominator, and that was the issue term why we couldn't plug in, because that was the 0 one, right? So once that cancels, we just get negative 1 over 6x plus 1. When you plug in 5 over here, 5 plus 1 is 6. 6 times 6 is 36. So plug-in method now works. The only reason why you use algebra in these problems is to eliminate whatever is making 0 in the denominator. And if you are not able to do that, the limit either doesn't exist or it goes to one of infinities. So if algebra doesn't work out, then you have one of those answers. Either does not exist, or positive infinity, or negative infinity. Yes?
I have another example.
Let me see, just check. Is everyone clear with this question? Are there any further questions regarding this?
If it was limit as x approaches -1, what would...
We are doomed.
Does not exist?
We have to, yes, because in that case you would have to graph 1 over x function that is shifted, right? The negative 1 over 6 is the vertical squish or stretch, so we don't have to worry about that. It would be a 1 over x problem that is shifted 1 unit to the left, and the limit would not exist. Yes, if this limit went to -1 instead of 5. Good. Any other questions regarding this particular problem? How about a smile or something? There we go. Look at that. Entire classroom. All right, what do you got?
The limit as x approaches 4.
Limit as x approaches 4.
Square root sign over fraction. So it's x cubed minus 2x squared minus 8x over x minus 4.
Nice. Most people immediately freak out when they see the square root over there. Now, the rules of limits in section 2.3, I believe, rules of limits have a rule which states that the limit of x to the p is the limit of x, everything raised to the p. So this square root simply gets kicked out, and we just focus on the problem, and then whatever we get from this limit, we'll just take a square root of that thing. So if this limit over here inside works out to be 9, then square root of 9 is 3. So we don't care about roots of any order. We don't care about any raised to the 107th power, because they all get kicked outside of the limit, and you just focus on the inside. So that's when you use the rules of limits, which is why we had that theorem, which says you can split the addition, split the multiplication, and division, all of them, right? So you had those 7 rules there. So now we are going to use our factor method. We still have to drag this square root throughout the entire calculation, and we have to drag the limit until we get to use it. So I can factor x, and I'm left with x squared minus 2x minus 8. On the bottom I just have x minus 4. I have to factor this further. So limit x goes to 4, and then I have x, and then we have what? X minus 4x plus 2. X minus 4x plus 2. So this is, algebra factoring. And this is where x minus 4 dies. Which makes us happy because we can now plug in. We still have the square root. And the limit over here is when you plug in 4 is 4, and then 4 plus 2. 4 plus 2 is 6 times 4 is 24, so the answer is square root of 24. And that's, 4 times 6, so 4 root 6. 2 root 6, yes. 2 root 6. Cool? So that rule, please review the rules of limits, right, so that you can pull this off. Aha, formula. Anything else? 4 minutes left, and then another 30 after that. Yes?
Can you do limit x goes to negative infinity?
I hope I can. Let's see.
The function is negative 5 plus 5 over x.
Like this?
Yep. All over 7 minus 1 over x squared.
Nice. Okay, so we are looking at this, and it has double fractions and all of that. So we are going to use the muscle from intermediate algebra, where we take a look and scan for the denominator with the highest exponent, which is x squared, and we multiply everywhere by x squared. So x squared divided by x squared is 1, right? So no arm done, and hope that that will transform the problem in a way we can use it. Oh, actually, wait, no. Hold on. This problem is done. It's negative 5 over 7. There you go. Done. Yeah. Yeah, that's it. Because we had that rule that I said when x goes to positive or negative infinity of 1 over x to any power is 0, right? We had this formula. Let me write formula. So you have, you know what? I'm not going to put a 1. I'm going to put any number. You can put any number. So now we have 5. So 5 over x, that's exponent is 1, right? So now you have this goes to 0, and this goes to 0, because x goes to infinity. Doesn't matter positive, negative. They actually join in the same point. So there you go. But negative 5 plus 0 is negative 5.
Okay.
Anything else?
Could we do limit as h approaches 0?
Aha! There we go. I was waiting for that one.
And then 3 over 5 plus h. And minus 3 over 5. All over h.
It's too high. We are going to do cross multiply to get this on a single fraction. So I have 5 plus h, and then I have 15 minus 15 minus 3h. And I'll put this h over 1. So limit h goes to 0. The 15s die out. I have negative 3h times 1 is negative 3h. And denominator is 5h, 5 plus h. Then this h dies. And I have limit negative 3 divided by 5 plus h as h goes to 0. So now I can plug in h goes to 0. That kills off this h. 5 times 5 is 25. So the whole thing, negative 3 over 25. So this is a 2.3 and 3.1 problem. You can practice this in both sections.
Could you tell us how many percentage is that graphing?
34.9. Because exam is next week on Monday, and today's Wednesday. So do you know how much of that exam I have?
No.
34.9.
I have 0. I can tell you. Yes. I'm going to make this exam on Monday morning. I procrastinate. It is one thing I really don't want to do. So when I wake up in the morning, I'll hate you all like on a double, because I'll have to kill like 3 hours because I have to solve, make sure there are no surprises, you know, and yeah, and all that stuff. So it's not just. And I can't pick problems at random, because then you go crazy. Anything else?
Earlier you said that there would be a replacement problem. What is that?
Well, I'd say you can't remember how to do number 5. You just use the 11th question instead of 5. You'll come up over here, maybe use it for number 3. Or maybe number 7. The best thing is when you have a question that is 4 points, definition of a function, and then the student uses a replacement question to replace those 4 points and messes it up. Do I get partial credit? Like, how much do you want? Because your replacement question is worth immediately the same amount of points as the question you're replacing. So if you're replacing a 10-point question, your replacement question is out of 10. If you're replacing a 4-point question, is out of 4. So, and it's the same amount of work because it's the same problems. Yes.
You said the quiz points go towards the test, right?
Yeah.
But you don't have any extra credit on the test itself.
Oh, hell no. Never. Never, ever, ever. I used to go as far at faculty meetings to say every professor who puts extra credit on the test should be shot. And yeah, and that's why they don't like me.
Do we have the guessing game on the first test?
Yeah. But let them be surprised and miss the day when I return them. So they miss it all. Anyway. Yeah, I have a lot of good ideas with that. Because it's pointless. 5-point exercise. Like, what does it do? Times 10% is 0.5.
Are you
What?
one of those people that gets like super heated when you start talking about politics?
No, I don't talk.
Okay.
I learned not to talk because, you know, there's when yeah, no, it's just when you have just like a bunch of trees to talk to, like why spend words? So I stopped. For years I tried and then I just gave up. I just, you know, I talk to those that want to listen and then we can come up with something, but drop the lowest quiz grade. No, you drop the highest one. I used that at NGIT. It did wonders. Yeah. Mm-hmm. Drop the highest test grade. You see, what happens? You tell me. What happens if I tell you, you have 3 exams, I'm going to drop the highest?
You gotta erase all.
You mean just with my class, of course, right? Just think about it. Just go through the motions in your head and think about what happens if I'm dropping the lowest or the highest.
There's no room for error. You drop the highest. You have to go.
What does that mean? I guess we're done over here.
You gotta go, yeah.
If you drop